Let's talk about gas and energy. Bill Nye here. Ever wonder why a balloon floats or what happens when you squeeze it? It's not magic, it's science. Today we'll explore the world of gases and the cool rules they follow, called the gas laws. We'll uncover Boyle's law, Charles's law, and Gay-Lussac's law, each showing how gases react to changes in pressure, volume, and temperature. And after that, we'll unlock the secret behind why some reactions happen on their own, Gibbs free energy. Ready to discover how the tiniest particles shape our world? Let's dive in. Science is the key. Let's turn it together. Welcome to the magic of Boyle's law, a fascinating rule that explains how gases behave when you squeeze them. It's almost like a science trick, but it's real. Back in the 1600s, scientist Robert Boyle discovered something amazing. When you squeeze a gas, its volume shrinks, and its pressure rises, if the temperature stays the same. This relationship is the heart of Boyle's law, and it's all about how pressure and volume are connected. Imagine holding a balloon in your hands. As you squeeze it, the balloon gets smaller and it becomes harder to press. That's Boyle's law in action. Less space for the air means more pressure inside. Or think about using a bicycle pump. When you push down, you force air into a smaller space and the pressure inside the pump rises. That's why it gets harder to push as you go. Scuba divers experience Boyle's law every time they dive. As they go deeper underwater, the pressure increases and the air bubbles they breathe out shrink. When they rise toward the surface, the bubbles expand again as the pressure drops. But what's really happening? Pressure is just gas particles zooming around and bumping into the walls of their container. The more they bump, the higher the pressure. When you squeeze the space smaller, those particles have less room to move, so they bump into the walls more often, and with more force. That's why the pressure goes up. Boyle's law isn't just for scientists. It's everywhere in our daily lives. It's at work when you breathe, when you use a syringe, or even when you open a soda can. So next time you hear that satisfying hiss from a soda can, remember, that's Boyle's law in action. Science is everywhere, making the ordinary extraordinary. The wonder of Charles's law. Jacques Charles showed that if you heat a gas, it expands, cool it, and it shrinks, if pressure stays the same. Hot air balloons rise because heated air inside expands, making the balloon lighter than the air outside. Take a balloon outside on a cold day. It shrivels. Bring it inside, it perks up. Charles's law explains why engines work and why bread rises in a warm kitchen. Heat it up, it gets bigger. Cool it down, it gets smaller. The universe follows these rules and so can you. Science is powerful. Our third gas law, Gay-Lussac's law, shows what happens when you heat or cool a gas in a fixed volume. This law is all about the relationship between temperature and pressure, as long as the amount of gas and the volume stay the same. When you increase the temperature, the gas particles move faster and collide with the walls more often, causing the pressure to rise. If you cool the gas, the particles slow down and the pressure drops. Heat a sealed can, and the pressure inside skyrockets. Too much, and it can explode. That's why you should never put a closed can on a stove or in a fire. The rising pressure can be dangerous, turning an everyday object into a potential hazard. Car tires heat up on long drives, the air inside gets hotter, pressure rises. This is why you might notice your tire pressure warning light coming on after a long trip, especially on a hot day. That's why you check tire pressure when they're cold. Early in the morning before you drive is the best time to get an accurate reading because the air inside the tires hasn't heated up yet. Gay-Lussac's law tells us that pressure and temperature rise and fall together if the volume doesn't change. This direct relationship is easy to see in everyday life, from pressure cookers to aerosol cans. Boyle's, Charles's, and Gay-Lussac's laws together explain how gases behave everywhere. Each law focuses on a different aspect, but together, they give us a complete picture of gas behavior. The invisible world of gas is predictable and follows clear rules. Scientists can use these laws to design safer products, predict weather, and even launch rockets. These laws keep us safe and help us understand the world. Isn't that amazing? The next time you see a pressure gauge or check your tires, remember, you're seeing Gay-Lussac's law in action. Now let's ask a bigger question. Will a chemical reaction happen on its own, or does it need a little push? This is one of the most important questions in chemistry because it helps us understand why some reactions just go, while others stubbornly refuse to start unless we help them along. The answer lies in something called Gibbs free energy. This concept is like a secret code that tells us whether a reaction is ready to roll or needs extra energy to get moving. If a reaction releases free energy, it's called spontaneous. Think of ice melting on a warm day or a log burning in a campfire. These reactions happen naturally, without us having to do anything. But if a reaction needs constant energy input, like charging your phone or keeping a battery full, it's non-spontaneous. You have to keep feeding it energy, or it just stops. So, you can think of Gibbs free energy as nature's ultimate yes or no button for chemical reactions. It's like a decision maker that tells us if a reaction will go forward or not. It does this by balancing two things: the heat released, which scientists call enthalpy, and the increase in disorder, known as entropy. Both are crucial in determining what happens next. Nature loves to release heat and get messier. That's why you see things like ice melting or gases spreading out. They're all about more disorder and energy flowing out. If both heat is released and disorder increases, the reaction is spontaneous. It's like getting a double green light from nature. But if either one doesn't happen, you'll have to keep adding energy to keep the reaction going, just like charging a device that keeps losing power. Gibbs free energy is like the universe's rulebook for change. It sets the guidelines for what's possible and what's not in the world of reactions. By understanding it, we can predict which reactions will happen, which won't, and even design new ones. It's a powerful tool for scientists and anyone curious about how the world works. Today, we uncovered the 3 gas laws and the secret of Gibbs free energy. These aren't just textbook rules, they shape everything from balloons to stars. Science is about curiosity, asking why and how. The universe is orderly, not chaotic, and you have the power to understand it. Be curious, experiment safely, and keep asking questions. Science belongs to everyone, especially you. Keep exploring, keep discovering, and keep thinking like a scientist. The world is full of wonders, and you're just getting started.